It was an honored second when the Andromeda cloud for the present transformed into the Andromeda Infinite Framework. The James Webb Telescope has perceived 6 universes that exist a portion of 1 billion years after the tremendous blast. This is incredible when you really look at the night sky. Making the rounds, a pinpoint of light at the point when broadened gives you one of these photographs from the Webb Space Telescope. It was an honored moment as the Andromeda cloud changed into the Andromeda world. For a long time prior, our cognition of the Andromeda world was confined to base discernments. In any case, with movements in advancement and the presentation of the James Webb Space Telescope, our perception has grown tremendously. Now, things are going to change as the James Webb Space Telescope has recognized upsetting signs coming from the Andromeda universe. These signs have sent shock waves through the academic community, leaving stargazers both inspired and curious. But what exactly do these signs mean, and why are they causing such a commotion among space specialists? Join us as just 2 minutes earlier, the James Webb Telescope shut down right after receiving upsetting signs from the Andromeda Vast Framework. Previously, we could see far beyond our eyes into the universe. Cosmologists trusted the Milky Way for being the whole universe. This shortfall of information was fundamentally because of limited advancement for seeing different inestimable frameworks and individual stars. At any rate, everything changed when we found the Andromeda world. It filled in as our most critical sign that the universe extends far beyond the Milky Way. In the 17th century, Galileo Galilei's initiating work with telescopes revealed the Milky Way's undeniable nature. He saw that the Milky Way had different stars, testing the winning idea of its specific meaning. Everything changed in the 1920s when Edwin Hubble saw distant objects beyond the Milky Way using the Hubble telescope. Edwin observed that these brilliant objects traveling through the universe were universes not exactly the same as the Milky Way. One of the frameworks was the Andromeda world, or M31. While this was the point at which we first saw the Andromeda world through a telescope, Persian cosmologist Abd al-Rahman al-Sufi first noted it around the 10th century. On record of mechanical types of progress in the 20th century, space specialists could see and sort out the genuine substance and exemplification of Andromeda. It is an indistinct cloud involving a gigantic universe of stars like our Milky Way. Our boundless neighbor is around 2.5 million light-years from the Milky Way. Since its discovery, the way we focus on Andromeda has altogether progressed. We have moved from ground-based discernments through telescopes to space observatories like the Hubble and the James Webb Space Telescope. Every movement in development has taken us higher than at any other time, helping us understand the secrets of the Andromeda universe. We currently have more information and insight into its creation and structure, making Andromeda a benchmark for considering the development of universes. This has uncovered more understanding into the greater working norms of the universe. Scientists believe that to have a superior perception of our universe and the Milky Way, we ought to focus on the relationship between Andromeda and the Milky Way. This is especially true given that the two frameworks will undoubtedly crash in around 4 billion years. While studies and assessments have progressed, the James Webb Telescope has recently gotten an upsetting sign from Andromeda. This upsetting sign confuses scientists, generally actuating questions concerning its cautious starting and possible implications. The James Webb Telescope's high-level sensors have recognized extraordinary development right inside Andromeda's community. The sign sent back to analysts shows results that contrast through and through from past discernments, dazzling scientists in general. The sign illustrates huge cycles happening inside the world, potentially associated with its truly enormous black hole or previously concealed events. Strikingly, one of the latest discoveries illustrates that Andromeda's mass may be a lot greater than that of the Milky Way, reshaping how we could decipher both infinite frameworks. The James Webb Telescope has moreover given detailed pictures and spectra of Andromeda, revealing the development of new stars and their compound designs. This new data is critical for understanding galactic development and the conditions for life. Additionally, the data from the telescope suggests extended development in Andromeda's dynamic vast center. This has, in the end, impacted its surrounding environment and is expected to shape its future development. Other than by examining the gravitational effects on stars inside Andromeda, trained professionals gain bits of insight into the scattering of confusing dark matter all through the vast framework. Ideally, This helps our understanding of its effect on the components at play in the universe. Sorting out dark matter and its impact on the universe is one of astronomy's most conspicuous questions. Late forward jumps by the James Webb Telescope have motivated various investigations as analysts examine the insider realities of Andromeda. With more information becoming realized, we now find out about the framework's past and future. So, what have we learned about the Andromeda world through various examinations? Andromeda has shown vital characteristics that separate it from various universes spread across the universe. Its sheer size commands thought, with late assessments suggesting an expansiveness crossing around 220,000 light-years. This figure makes it one of the greatest galactic frameworks in the local group, much more significant than the Milky Way. This enormous extension adds to its mass, containing a normal trillion stars, beating our vast framework in star count. Research also sees the framework structure as charming. Not like an ordinary winding framework, Andromeda has an expanding center and a thick center encased inside rings of dust and gas. This is without a doubt a rich ground for persistent star development. Such features show a dynamic universe made by steady processes forming its advancement. Among its numerous components, one of specific interest is its center. It is described by a twofold zenith release, demonstrating the presence of a supermassive black hole, but not exactly equivalent to the Milky Ways. This offers huge insights into the nature and activities of these huge matter-eating openings. The Andromeda world is similarly encircled by a circle of sublime trash, including stars, planetary, and globular gatherings, crossing numerous enormous quantities of light-years in expansiveness. This tremendous covering tells a captivated, organized story of the world's intriguing start and history. The 460 globular gatherings tracked down in Andromeda likewise offer information into the plan of stars in their first stages, giving a clear explanation of the development of star gatherings and the early new development of the universe. In figuring out the secrets of Andromeda, stargazers are the slightest bit closer to understanding the tremendous relevance of dark matter. At any rate, one request holds up. How do they represent its bewildering nature and the work it plays in the components of vast frameworks? Andromeda boasts another undeniable feature: its satellite universes. Its crown structure is contained in excess of 20 smaller infinite frameworks, and some of them are going through streaming, denying their stars and gas. This cycle involves a greater astronomical framework pulling in and destroying bordering minimal astronomical frameworks. This shows the dynamic nature of huge development and describes how universes create and connect with one another over an extended time. So, what does the future hold for the Andromeda framework? The shape and direction of its development entrance cosmologists, as well as those attempting to fathom the universe. The possibility of its encouraging from a twisting to a ring universe is partly essential in Andromeda's progression. Verification centers on a collaboration that could brief other captivating mixes, maybe from grandiose effects or close relationships with various universes. If Andromeda truly is pushing toward this way, it suggests that it has experienced various associations with other astronomical frameworks since its first encounter with the world. Eventually, Andromeda's future depends upon the unpreventable accident with the Milky Way, as demonstrated by these models. The effect is estimated to primarily happen 4 billion years from now. The result of such an effect is the formation of a new world from these two giant stellar entities. Anyway, it is a part of inestimable advancement. At any rate, due to the gigantic distances between the universes, this infinite crash is certainly not an immediate quick impact. After the effect, the two infinite frameworks would be significantly modified, outlining new shapes and associations. The correspondence of their gases and dust will work up new rounds of star creation, inciting a colossal presentation above as the mixing objects shimmer brilliantly. Eventually, such a boundless event will result in the development of a lone round universe. This kind of effect is not uncommon, as the universe has a long history of such events. At any rate, our immediate interest makes it an event essential to us. Additionally, the expected crash of the exceptionally colossal black holes at the center of the two universes adds more complexity to the radiant show. This suggests a perplexing and significant nature of tremendous advancement. The union is expected to convey impacts for the issue being immersed by the black hole, which will convey wide radiation. This association offers significant data about how vast frameworks move throughout their life cycle and how black holes impact this development. In any case, it raises a crucial issue. What will happen to our close-by planetary group after this combination is formed? Off by a long shot to a total obliteration of the nearby planetary group, the close-by planetary group's heading and conditions could be changed substantially. This suggests possible orbit shifts or even launch from the newly emerged vast framework. To handle this mechanism, scientists can concentrate on the scale of similar events happening and contextualize the possible fate of our own universe. It is significant to fathom that an accident between stars is an extraordinary event in space due to the enormous intergalactic distances. In any case, the gravitational change could agitate stars' stable orbits, causing a few stars, including our Sun, to head in a different direction. Such a change could substantially affect the climate on Earth. Maybe one of the most essential changes people could experience is creating some distance from or closer to the Sun. This could prompt one or the other warming or cooling influences. A hotter climate could make ice caps liquefy and sea levels rise, while a colder one would ignite another ice age. On top of that, the estimation of such a plan could block radiation levels from reaching Earth, making significantly more challenging conditions. The Milky Way and Andromeda galactic frameworks are destined for a close-to-come effect, an event that will reshape the endless scene. This impact, estimated to occur in around 4 billion years, will be perhaps of the most critical event in the universe's plan. As the two universes wind toward each other, their common gravitational attraction will begin a stunning dance of immense powers. The accident isn't a direct impact, but a consistent mixing process. During this cycle, the astronomical centers will eventually merge, provoking the development of a new combined vast framework. In the early periods of the accident, communications between the galactic plans will set off an extraordinary star formation. The gravitational agitating effect will pack interstellar gas and dust, lighting new star births. This starburst development will make an explosive show of radiant fireworks with newborn stars illuminating the merging universes. The collision of the Milky Way and Andromeda is an event that holds vast implications for our understanding of galactic evolution. While the exact nature of this collision is still being studied, it offers astronomers an unprecedented opportunity to observe the intricate process of galactic merger. Such an event isn't an immediate cataclysmic disaster but a slow and complex process where the forces of gravity will influence the shape and structure of both galaxies over billions of years. In fact, the gravitational interaction between these two massive galaxies will likely trigger new star formation as gas clouds compress and ignite, producing a brilliant burst of new stars in the process. One of the most fascinating aspects of this collision is how the black holes at the centers of the two galaxies will behave. Supermassive black holes, such as the one at the heart of both Andromeda and the Milky Way, exert an immense gravitational pull that can draw in surrounding matter, including gas and stars. As these galaxies merge, their black holes will spiral toward each other and eventually coalesce into a single, supermassive black hole, releasing an immense amount of energy in the form of gravitational waves. This process could help scientists detect and study these enigmatic cosmic phenomena in ways never before possible, offering insight into the nature of black holes and their role in galactic evolution. Furthermore, the merging of the Milky Way and Andromeda could cause a dramatic shift in the orbits of stars within each galaxy. While stars themselves are spaced far apart, the gravitational interactions that occur during such a merger can alter their trajectories. Some stars might be ejected from the newly formed galaxy, while others might be drawn toward the newly formed central black hole. This cosmic dance will lead to a restructuring of the star systems within the merging galaxies. On a more local scale, the effects of the collision may influence the fate of our own solar system. While the Sun itself is unlikely to be directly affected by the merger, the gravitational forces could alter the orbits of objects within our solar system. It's possible that Earth could be displaced within the newly formed galaxy, moving closer to or farther from the galactic center. This shift in position could alter the amount of radiation Earth receives, potentially changing the climate and conditions for life on our planet. Although the collision is billions of years away, studying this process can help astronomers understand the eventual fate of our galaxy and its relationship with other galaxies in the universe. This cosmic merger provides a snapshot of the dynamic processes that shape the universe over long periods of time, and the James Webb Space Telescope's observations are only beginning to reveal the secrets behind these magnificent galactic transformations. The knowledge gained from studying Andromeda's ongoing development will continue to shed light on the nature of the universe and the forces that govern its evolution.